Yes, welcome back. Let's just continue. Just download the Central Processing Unit CPU, but I read it a long time ago, but I like to read it again. So I will go to my bed and stay in my bed. Let's try to read more of this. Still have a lot of power on my camcorder.
(32nm) process. The 32nm node is the step following the 45nm process in CMOS, MOSFET, semiconductor device fabrication. 32 nanometer refers to the average half pitch, i.e., half the distance between identical features, of a memory cell at this technology level. Toshiba produced commercial 32GB NAND flash memory chips with the 32nm process in 2009. 1. Intel and AMD produced commercial microchips using 32 nanometer process in the early 2010s. IBM and the Common Platform also developed a 32nm high metal gate process. 2. Intel began selling its first 32nm processors using the Westmere architecture on 7 January 2010. The 28nm node was an intermediate half-node die shrink based on the 32nm process. The 32nm process was superseded by commercial 22nm technology in 2012. 3. 4. Technology demos. Prototypes using 32nm technology first emerged in the mid-2000s. In 2004, IBM demonstrated a 0.143M2 SRAM cell with a polygate pitch of 135 nm, produced using electron beam lithography and photolithography on the same layer. It was observed that the cell's sensitivity to input voltage fluctuations degraded significantly at such a small scale. 5. In October 2006, the Inter-University Microelectronics Center, IMEC, demonstrated a 32nm flash patterning capability based on double patterning and immersion lithography. 6. The necessity of introducing double patterning and Hyper-NA tools to reduce memory cell area offset some of the cost advantages of moving to this node from the 45nm node. 7. TSMC similarly as double patterning combined with immersion lithography to produce a 32nm node 0.183M26 transistor SRAM cell in 2005. 8. Intel Corporation revealed its first 32nm test chips to the public on the 18th of September 2007 at the Intel Developer Forum. The test chips had a cell size of 0.182M2, used a second-generation high-gated electric and metal gate, and contained almost 2 billion transistors. 193nm immersion lithography was used for the critical layers, while 193nm or 248nm dry lithography was used on less critical layers. The critical pitch was 112.5 nm. 9. In January 2011, Samsung completed development of the industry's first DDR4 DRAM module using a process technology with a size between 30 nm and 39 nm. The module could reportedly achieve data transfer rates of 2.133 bit/s at 1.2V. compared to 1.35V and 1.5V DDR3 DRAM at an equivalent 30nm class process technology with speeds of up to 1.6 bit/s. The module used pseudo-open drain pod technology, specially adapted to allow DDR4's DRAM to consume just half the current of DDR3 when reading and writing data. 10. Processors using 32nm technology. Intel's Core i3 and i5 processors, released in January 2010, were among the first mass-produced processors to use 32nm technology. 11. Intel's second-generation Core processors, codenamed Sandy Bridge, also used the 32nm manufacturing process. Intel's 6-core processor, codenamed Gulftown and built on the Westmere architecture, was released on the 16th of March 2010 as the Core i7-980X Extreme Edition, retailing for approximately $1,000. 12. Intel's lower-end 6-core, the i7-970, was released in late July 2010. Priced at approximately $900. AMD also released 32nm SoI processors in the early 2010s. AMD's FX series processors, codenamed Zambezi and based on AMD's Bulldozer architecture, were released in October 2011. The technology utilized a 32nm SoI process, 2 CPU cores per module, and up to 4 modules, ranging from a quad-core design costing approximately $130 to a $280 8-core design. In September 2011, Ambarella Incorporated announced the availability of the 32nm-based A7L system-on-a-chip circuit for digital still cameras, providing 1080p 60 high-definition video capabilities. 13. Successor node 28nm and 22nm. The successor to 32nm technology was the 22nm node, per the International Technology Roadmap for Semiconductors. Intel began mass production of 22nm semiconductors in late 2011-14, and announced the release of its first commercial 22nm devices in April 2012. 3. 15. TSMC bypassed 32nm, jumping from 40nm in 2008 to 28nm in 2011. 16. References. Toshiba.
Good. Let's just stop and continue.